Hello and welcome back. And in today's video, I'm gonna show you what happens when you do the logical operation for signed and unsigned. So let's see that we've got this if statement, and if you think intuitively, this will give um, this the statement that is in the body of if condition, and in the variable I -1 is assigned, and in the variable 0 the number 0 is assigned. However, it is not what you think, and it will give the result in the body of else condition. So let's run it and see the result. And if you look at the result, it gives what is in the else statement, and that contradicts what we think intuitively. And why the reason why this happens is that because um, if you do logical operation for signed and unsigned, the signed type int is automatically converted to unsigned, and because the number -1 can be represented in full ones for in binary form. So if you declare a type in int type in signed type, and it basically the most significant bit gives the negative number, so it gives -1. And as the type int is 32 bits, and when you assign -1, then it is sign extended to fill in 32 bits, so it will have 32 ones. So as it filled it as it, this is filled with 32 ones, the most you give the number what is defined in unsigned max. Unsigned max gives the largest number that you can represent with um, unsigned int. So if you print out unsigned max, let's look at the result. Um, int max, and run and see the result. So you unsigned max gives this amount of number. So pick as this in this variable I, this much number is stored. So as 0 is not greater than this number, it becomes this if condition becomes false. Therefore, it gives the statement that is in the body of else condition, which is -1 is greater than or equal to 0. Um, Therefore, then let's delete this and then pass I for the expression, pass constant 0 for the expression. So run and see the result. Now this gives the correct result, -1 is less than 0. Now let's put u suffix and see the result. This u suffix um, means that interpret this number, this constant, as unsigned. If you do not have any suffix, it automatically um, treats this number as signed type. However, if you put suffix u, so it will give unsigned type. And because it's the logical operation for signed and unsigned, this signed type I will be automatically converted to will do implicit conversion to unsigned, and it will give what is defined in uint So as this becomes as zero, the number zero is not greater than uint it becomes false and it will give the statement that is in the body of else condition. So let's see if it's true by running it. So if you look at the result this time, it gives what is in the body of else condition. -1 is greater than or equal to 0. So now let's um, pass 0 and see the result. And it gives the same result we have just have seen for earlier for the same reason. And now this time, let's remove on and let's pass signed in for the expression for this logical operation. Now it will give the correct result. And see the result, run and this time it gives -1 is less than 0. And let's just comment out this. And then now this time let's remove sign and see the result. So if you look at this time, it gives the correct result. So if you do not have any prefix on the declared type, it automatically gives the sign type, and you can still put suffix to show it explicitly. And so this is all for today, and we've covered what happens and how the calculation is done when you do logical operation for signed and unsigned type. Um, and in the next video, we're gonna see what happens for arithmetic operation for signed and unsigned. So see you in the next video and thanks for listening.